Now we must take the SketchUp model of all of the pieces that you see right here, and we're going to convert them into a STL, or a surface tessellation file, which basically records all of the geometry of each of the pieces. Okay, so you will actually be able to record all of that data in coordinates, and you will be able to take all of that convert that into the STL format, which will then be able to be understood by the Makerware program or any 3D slicing program that is used with the 3D printer at your school. So in order for this to take place, I need to go up to the File menu, and there should be a plugin already installed for you which will allow you to export the model into STL format. So it might say export DXF or STL. You want to click on that option from the File menu, the drop down File menu. It might say no object selected and export entire model. Hit yes, and then it's going to give you some STL file location options. And I want to get rid of the untitled part of this. We can leave the Actually, we're going to pull that away. We're just going to make puzzle block. You want to keep the title of or I should say the file name, to be as short as possible so that you don't have any problems when you're saving it. So file name will be puzzle block. Puzzle block, and don't forget to put the file extension. The file extension, since this is not an SKP, it's not a SketchUp file, this is now an STL file, a stereolithographic file, or commonly known as a surface tessellation file. So .stl, and we're going to save that right onto the desktop and hit save. And it's going to say 112 faces, export 0 lines, exported 300, object ignored, hit OK. Let's minimize this now, and let's open up our 3D slicing program. What I will be using is Makerware, since I use MakerBot replicators in my classroom. So you may be using the Affinia or any other 3D printers. So whatever the 3D slicing program that you will need, that is what you will be needing to open at this time. So now let's go in and actually add that STL file. So let's go in and actually look for the STL file that we've saved, and mine is known as the puzzle block. Open it, and it should now appear on the screen, as you can tell right here. And I can change the color. I'm going to change the color right now so that I am able to see what I'm actually looking at. Let's make it green. And it's all going to be one color, and that's okay. Then I'm going to actually look at the top view. If I want to center this, I can go to move it towards the middle of the screen or middle of the print bed. If I wanted to duplicate this multiple times, I would just simply highlight it all, and then Control-C, Control-V, and there's a duplicate, and then just move that in line if that is what I wanted to do. But I only want to print one, so let's just put one puzzle block right in the middle of the print bed, and then let's set up our print settings. So, print settings. As you can tell, I'm printing for the Replicator 2. That's what it says down here at the bottom of the screen. If you have a Replicator 2X, it's important at this time to make sure that you have the correct MakerBot selected, or the correct 3D printer. So you go up to the MakerBots drop down, and then select the type of MakerBot that you are currently working with. So I'm using the MakerBot 2, the Replicator 2. So that eliminates a lot of other options that I would need. For example, with the Replicator 2X, you can print in dual colors, but at this time I only have one model on here, so I can only print in one color anyways. So Replicator 2 will be perfectly fine for this operation. Now, all we need to do from here, I'm zooming in a little bit, is to hit the Make button on the screen, and I can export it to a file if I'm not directly connected to the MakerBot or tethered to the MakerBot through a USB cable, just like a printer that you would have connected to your computer at home. I can export it. If I have it directly connected, I will not have export options. It'll actually let me print, just like you would hit print from your computer at home. So I'm using the Replicator 2. The material is already selected, that is the PLA. The Replicator 2 only uses PLA. The other one, the Replicator 2X, uses the ABS. Do I need any wraps or supports? No, I shouldn't need them on the Replicator 2. Resolution, you could leave that at standard, or you could go to low. High is not necessary. Low is probably all you need for this application. Now, if you wanted to speed up the process so that it would take less time to print, you can go into the advanced options, and that is where you'll be able to actually set up how you want the actual layers to be sliced. Okay, remember that we're basically taking the 3D objects, which in this case the puzzle pieces, and we're taking a knife and slicing each one of those layers into a thickness of, in this case, the layer height is 0.30 millimeters. Okay, so the layer height on the lowest setting is 0.30. Going to standard, obviously the layer height shrinks all the way down to high, down to 0.10. And I believe you can get the layer height all the way down to the thickness of a standard sheet of paper, which is what they say on the website for MakerBot. But, you know, like I said, low is all we need, because as you can tell in parentheses it says that that is the fastest resolution, the fastest build that you will get. You can change the temperatures, which I suggest not to, and the speeds, those are all variable controls here right from the advanced options. The number of shells, that is actually how many layers are not layers, but how many lines trace the overall object profile. So the 2D drawing, the orthographic drawing, that's basically like saying you would outline it twice. If you were to increase the number of shells, you could do that by simply using these arrows for increasing the thickness or decreasing the thickness, okay, of how many shells. And the infill is basically a grid work, just like the grid work that you see in the background, that can be in different patterns. At this current build of Makerware, they are using a hexagon shape, and the hexagon shape can be increased or decreased using the percentage of infill. So a 10% infill will be perfectly fine. The higher the infill, the more lines. The lower the infill, the less lines that make up the hexagons, and the hexagons will actually look bigger. Alright, so we're ready to export. Hit export, and then I need to locate the SD card that I'm going to save the file onto. I don't have any SD cards loaded, but I'm just going to put it right onto the desktop for now. Okay, and then that's where I want to save the file name to whatever I want. So I'm going to name this puzzle sample, and hit save. Let's move this in. Hit save, and as you can tell at the bottom right corner of the screen, it's slicing all of those pieces into the 0.30 millimeter inch, or I'm sorry, 0.30 millimeter thickness. That's the height, and it's adding 2 outside layers or outlines, and that is it. So all we need to do at this point is take the SD card over to our MakerBot, insert the SD card, and go through the menu options until you find the build from SD card, and then you will select the puzzle that you are creating, and then hit print.